fantastic on-off button that you do require. All right, so let me introduce, first of all, we're talking about AMI analytics here using for Transformer Health, and we will explain the project at Southern Company that was started last year. And here with me, I have my guest, Julia Clark. Julia is a distribution research engineer for Southern Company, Power Delivery Research and Development Group. She's responsible for all distribution research efforts across the Southern Company footprint and aids in helping the company find new ways to maintain a stronger, more reliable and resilient grid while the company pushes towards a net zero future. Also, Julia, for the past 7 years, has worked for Southern Company. She's worked in distribution, transmission, protection and control, field services, and most recently with Power Delivery Research and Development. Julia holds a bachelor degree in electrical engineering from Florida A&M University and is currently pursuing a master in renewable energy and sustainability system at Pennsylvania State University. So please welcome Julia as a speaker. And so I will have a brief introduction of what APM is. So if some of you have heard my presentation was done yesterday. Asset management system, this is an analysis done by Gartner. Gartner positions the APM within the system for asset management. APM is here, of course. So Gartner finds 3 systems. One is the enterprise asset manager, which we all know, for the most consolidated one. Then APM is let's say the new system coming along, and then AAP, this is asset investment planning. The system communicate within each other, they interchange information. APM needs asset data, technical characteristics, but they also need technical data coming directly from process and condition of the assets, right? APM produces alerts and notification and passes information for long-term planning up to the AIP, and then for schedules and triggers events to the to the enterprise asset management. In terms of product, we propose OneSet Grid, APM as our product. Here we have integration with other players in the market for enterprise asset management. So a brief concept of asset health and strength. Asset health. So this is, imagine a generic asset, and statistics tell us that information tells us that once the asset is installed, it's got the health of the asset is considered 100%, and then the asset health slowly decays until it reaches a point where its lifetime ends. Why does the lifetime ends? Because this is the normal operating stress. So when the operating stress crosses the strength of the asset, then the asset is meant to fail. However, what happens is that during the life of the asset, we have peaks of stress. Think about a wood pole that experiences a strong wind, for example, or snow on the cable, so there's a lot of weight. That's a peak of stress for that particular asset. In terms of transformer, a peak of power demand, for example, that was not expected in the design of that particular asset. So if the strength of the asset is decaying and you have this peak, we have actually an unexpected early failure. This is the early failure that statistics do not spot from normal use of assets. So the asset health index is what we calculate, and it basically has got three main scope: optimize the life cycle cost of assets, analyze the risk of failure based on condition of the asset rather than on age, and then a plant maintenance and investment based on asset condition. This gives a very important information for long-term planning and to organize investment in that space. Within the asset performance management, we have 2 main aspects. One is predictive. Predictive is normally related with highly sensorized assets, big assets like rotating machinery, for example, or large transformers. They have plenty of sensors because their cost justifies it, And so we can do predictive. We have a lot of information coming. We can understand if the functioning of the asset is decaying, and that basically gives us an idea there is an underlying problem. However, we have a number of assets in the grid which have no sensor at all. They're normally used to failure, and that's why we came up with the asset health concept. So normally low-cost assets, low sensorization, but the failure of this asset may actually have an impact on the image of the company and directly an impact on service to customers, or even a risk of fire, for example, or other major events that may compromise the company, the organization, the utility. The health index that we used, to calculate the health index, we used two methods, and we actually blended them. We have you see the method over there. One is Toronto Hydro. Toronto Hydro for 15 years has been storing very detailed information about their assets, and they came up with a methodology to say, okay, if we have all this data, then we can calculate the health index based on a number of assumptions, engineering assumptions, and other assumptions that we will see later. And the C9 is a collaboration between the UK and Denmark. They came up with another methodology to estimate the asset health, and it's actually used in UK by utilities to present their investment plans. They basically present the asset health to the Ofgem, which is the PUC over there, and they will say this is the investment and this is justified by the code of the C9. We blended these two together because Toronto Hydro requires a lot of information, a lot of data. C9 requires less, but of course the C9 gives less quality of information, less detailed information than Toronto Hydro. We blended this together, and we came up with our asset health, and then we have, of course, the input from clients that personalize, that customize the model that we use. What is a model for us? I'm going very fast so I can pass the word on to Julia. We basically define a data model, an health index model by using different inputs. This is normally signals, information comes from the field. We calculate a number of sub-condition parameters, right, by multiplying and giving different weights to different inputs. And then we calculate normally 3 different larger coefficients that contribute to the health index. To do directly a use case, here is, for example, a line voltage regulator, right? We have, this is the physical condition. With this, when we have to inspect or just know the information about this physical condition, this will be the control system. So we evaluate how the control system is performing by using these 3 information, and then a concept of reliability, which is basically age. Loading will come from the history of operation of this device, and then number of outages and number of operating count. So this is an example of where we would model the assets to give the information. This is the home page of APM, right? You have an overall view of all the assets with their health index information. And then eventually, which is green, it means that it's good health, and then it's yellow, it's a bit of risk, and then red is at risk. Then you can go down for every asset, you can go down to further detail, so you know the first level of coefficient that we saw before, or we can go down into a further level, and we know the coefficients that are underneath that contribute to that particular asset. And then we can go even down to see exactly how that lower layer of input information is stored in the system. So overall view for planning reasons, and then going down for more engineering consideration of the asset. How many assets have been modeled? There's a significant number of assets, and you can see here the number of assets. There's 23 different types of assets that have already been modeled and available in APM. And now I pass the word on to Julia, thank you, to talk about the experiment, the project in Southern Company.
All right, good morning, everyone. I'm Julia, as Giovanni introduced me. So Southern Company partnered with ACS to build us this health index matrix. And so this is just kind of an overview of Southern Company. And this project was specifically focused with Alabama Power. So these were the objectives of the project. We took 100 pole-mounted transformers, and they analyzed the data for us, and they were able to come up with results that we hope would give us more insight into the health of the transformer, and then eventually reduce O&M cost and, kind of maybe even factor into supply chain ordering as well. So this is the health index model, and for the project we had in Alabama, we focused on this middle section here, the reliability, the one that's kind of bolded. And so we have the location factor, the loading history, and then the age factor. And so these were all conditions that played into how we got our health index score. For this POV, we did not include the physical condition or the connection insulation. And at the time, we excluded both of those because that was just information that we did not have readily available for the length of the project that we selected. So this is kind of the overview of the project. Started off with data collection, then it went into the building and testing, and then user training and all of that. So we are pretty much in this phase right now. We have gotten all of the data. We worked with the ACS team in Spain, so they analyzed all of that data, and we have put it into like the health dashboard that Giovanni displayed earlier. So now we're in the mode of, okay, what is this data, and trying to analyze it and get a better look at the transformers that we assessed. And AWS housed our cloud for all that stuff. And so this is probably what most of you are wanting to know. So we sent them all of our AMI usage data. And so one thing that we did learn from the project was that you're kind of only as good as your data. And some of our AMI meters don't read on 15-minute increments, or some read every hour, some read every 2 hours, some read every 3 hours. And so you're kind of getting an aggregate of whatever that meter's timing interval is. And so as you can see, due to that, we had gaps within our data. So this is the raw data that they sent, and then you see here we have this big gap in the data. So the team with ACS had to build that synthetic data to fill in those gaps so they could get the right calculations. And so this is how they were able to get those calculations. So we sent over the data, and then they were able to interpolate this data. They applied the 1 hour SREMA curve to the 1 hour interval. Then they converted that to the hourly KWH, then did the 15-minute interpolation. And then we had to convert KWH to KW. So I actually did send them, on top of the actual usage data, the peak load data for all those transformers. So they had that as well. And then they did the analysis of the curves and rebuilt that historic load profile for those transformers. And so this is one of like our health dashboards. So as you can see, you've got the location over here, kind of the score at the top, and the different scores along here. And then within the reliability, one of the bullet points that was in that reliability hierarchy earlier was the location factor. And so they were able to do that for all of our transformers. So you have the condition parameter factor here for corrosiveness, environment, weather, tornadoes, which kind of gives us a good insight of how did these events affect the integrity of my transformer. And then we have a risk matrix. So the cool thing about the risk matrix that I like is that just because I have a transformer that is showing maybe a health alert, which is red, that doesn't mean that it has a high risk of failure. So I can have a transformer that's, they say it's about to fail according to the health index, but when I look at my risk matrix, and it's in this lower risk zone. So with our supply chain group, they can kind of figure out, based on this risk matrix, how do I need to prioritize my transformer ordering? Is it falling into this high risk area? Is it medium risk or the lower risk right here? And the beauty of working with ACS is they had these predefined risk matrices, and you're able to manipulate whatever you need to. So if you want to change one of the risk matrix factors or weight it differently, you're able to do that. And so I just thought that was a pretty cool feature that we're able to do. And another cool thing is that you can actually look out into the future for your risk matrix. So it kind of helps with future planning and kind of what do I need to order, things of that nature. And so now we're just kind of looking at what are the next steps we would like to take for this project to get better results and more insight into our actual transformer. And so for Southern, we are now looking at adding this physical condition layer into the overall health index ranking. And so what that looks like for us is, okay, if I have some type of drone imagery or LiDAR, something like that, does that give me a better result of the health index if I layer that on top of the AMI data? So that's kind of the next steps we're talking with ACS about is, okay, we know what it looks like just using the AMI data and analyzing it with the reliability, but if I add this physical condition, does that change my health index score at all? Or, does it add or subtract? So just trying to see if we can get a better overall picture if we add additional layers to the project. So that's all I have for right now. I'll open it to any questions you may have.
Sorry about that. She had a pop-up during
Oh,
the entire presentation.
It was fine. But yeah, if you guys have any questions, I'd be happy to take them. I'll try to answer them as best as I can.
What kind of sensor data do you have feeding into the matrix, and how do you, what's the methodology if you've got a particular alarm that's saying condition red, but the matrix is telling you, yeah, but it's maybe not something we need to worry about right now. Can you explain that a little bit?
Yeah, so I'm just going to repeat your question. Do we have any sensor data that's layered into the project to kind of add another layer of analysis to the APM dashboard? If the sensor is telling me something is good or bad, does that equate to what the dashboard is telling me? So no, to answer your question, we do not have any sensors on the transformer, but that is something we're looking into. It's something Giovanni can probably speak a little more about, but we didn't, for this project, we didn't look at any transformer sensor data and incorporate it into the health dashboard to see if that gave us different results.
So what is feeding?
The AMI data is just true AMI data. So it's lower cost because I don't have to put a sensor on the transformer to analyze the health. I'm just using data that I already have stored in my system. It's just sitting there. So a cheaper solution, so to speak, but to your point, layering on sensor data could possibly help.
With them, we decided to use AMI data because it was readily available, right? And these are devices which do not have sensors because just the number of them in the field and the cost of the asset does not justify going and installing sensors. So there was actually an R&D project say, how can we get information on metering data? And one of the things we had to do with data was actually to build the data that was before the smart meters were installed. Because 2 years of data from when the smart meter was built, but maybe that transformer had been there for 15 years. So also using population growth information, also using weather information to understand how that particular asset had been had undergone stresses. And the other thing, she was showing the different, we had to pass from energy information, so accumulated energy information, which was the meter was going into power, 15 minutes power, and that we use the artificial intelligence and the forecasting to understand going from a point of energy into actually the derivative of that was the curve, and to get the power, because the transformer was sensible to power rather than the energy. So
when you say the AMI data, it sounds like you're gathering data about the network at large, and you know where that transformer fits in, you know the energy through, you know all the other touch points out there. From that, you're extrapolating data that suggests this transformer has been exposed to this, and that feeds into the matrix. Am I getting that right?
you can associate a number of meters that are served by that service transformer. So you have a transformer associated, let's say, to 10 meters, 15 meters. So you're using all that, you're summing, you're aggregating all that energy, and you say, okay, this is the energy that has passed through that transformer. And then from there, the power, of course, of the transformer. Yep. All right. Thank you very much. I have to jump into my next next presentation over there.
If anyone has any further questions, I'll be around though. So if you just want to know more about the project, I'd be happy to answer.